Hello and welcome to Amulya's Academy YouTube channel. In this algorithm video series, we are discussing binary search algorithm. Today, let's write a Python program to implement binary search algorithm. So here we have binary search algorithm. We'll follow these steps to write the program. So first, let's talk about the input. Here input is a sorted list and a target value. So in the Python file, you can directly take inputs like this. First one is the numbers, a list with sorted elements and a target value. You can take inputs directly like this, or we can take user inputs. For that, we can do like this. First, we'll ask the user to enter how many elements you want in the list. So number of elements in the list, that is an integer value. So we'll convert the input to integer and we'll store that value in the variable n. Then we'll print this message, enter numbers in ascending order. Because here we want numbers in the sorted order, I'll ask the user to enter the numbers in the ascending order. Next here, to create the list, we'll use list comprehension method. We'll use int input because we want all the integer numbers as the input. So input function and convert that to int using int function. Then here we'll use list comprehension method to create this list. Then for target, we'll ask the user to enter the target element like this. Target element is also an integer value, so we'll convert the input to integer using int function. Okay, so this is about input. Next, to search the target element in the given list of numbers, we'll use binary search algorithm. So let's define a function for that. Let's define the function called binary search. Use def keyword and binary search is our function name. And here we need a list. So I'll take list name as numbers and a target. Okay, two parameters, that is the two inputs for binary search algorithm. Next, start search with the sorted list. Then set two pointers, low and high. Low is at the beginning, high points to the last index. So what this low and high pointers will do? It will represent the search area. Here, instead of checking each element in the dataset one by one like linear search algorithm, binary search narrows down the search range by half with each step. That is, first we'll take list of elements like this. These are the index. Then we'll take two pointers, low and high. Now this is our search area. Next, I'll find the middle element in the list. And I'll compare the target element with the middle element. If it is equal, then we found the target element. We are done. Return the index and stop. But if target element and middle element is not a match, then what we need to do is we need to compare the target element and middle element. Whether middle element is less than the target, we need to check this. If it is true, if middle element is less than target element, then that means our target element is present in the right side of the middle element. So this will become our search area. Because numbers are sorted here, the target element can't be present in the left side. We won't search in the left side. We'll only focus on right side. Now if this condition is not true, if the middle element is not less than the target element, then we'll check this condition. If middle element is greater than target element, that means target is present in the left side of the middle element. Because numbers are sorted here, right? That's why this will become our search area. So we'll search the numbers here. Here when low is less than high, that means we have more than one elements in the search area. When low is equal to high, we have only one element in the search area. We need to check that. If low is greater than high, it means search space is empty. We have checked all the valid positions. So that's why we need to do this process again and again until low becomes greater than high. When low becomes greater than high, we need to stop. If low pointer goes beyond high pointer, target is not present in the list, so return -1. Otherwise, we'll return the index of that element. Okay, so output is index if the target is found, -1 otherwise. Here we need to execute this multiple times, right? And we can do this using loops or we can use recursive functions. That is, we can write this program using recursive approach as well as iterative approach. An iterative approach repeats a set of instructions using a loop, while a recursive approach solves the problem by having a function call to itself. until a base case is reached. Today, we'll write this program using iterative approach. That means we'll use loops. And here we have a condition, that's why I'll use while loop. So to write the program, first what we need to do, we need to set 2 pointers, one is low and high. Low, I'll take index as 0, the first index, and high, last index. For that I'll find the length of list minus 1. If list contains 5 elements, then the last index is 4, so length of numbers minus 1. So now we have 2 pointers, low and high. Next what we need to do, when low is less than or equal to high, we need to check for the elements. We need to search the target element in the given list in the present search area. For that, I'll use while loop, while less than or equal to high, then only find the middle element first. Here, first we'll find the index. To find the middle index, I'll use low plus high truncated division 2. I'll use this formula to find the middle index. Then we need to compare the middle element with the target element. For that, I'll use if condition. If numbers of mid, that is middle element, is equal to target. If it is true, then return mid. Return that index. That means we found our element, then just return its index and we are done. Else, I'll use elif here. I have another condition to check. If it is not equal, then let's check numbers of mid, that is middle element, is less than target. If it is true, then what I need to do is I need to change the low pointer. Low is equal to mid plus 1. Search in the right side of the middle element, because target is greater than the middle element. If it is present, then it must be present in the right side of the middle element, because numbers are sorted here, that's why. Then here I'll take else block, that is the condition when target is less than the middle element. What I'll do is I'll take high equal to mid minus 1. If it is false, then that means target is present in the left side of the middle element, so I'll take high equal to mid minus 1. This will execute until we'll found the target element or low becomes greater than high. Then here, if low becomes greater than high, then we need to return minus 1. Not found scenario. If target element is found, then we'll return its index. If not, if low becomes greater than high, it will return minus 1. Okay. Next here, you can call the function like this, binary search. Be careful about the name of the function. Here numbers and target. And this function will return a result, right? Either it returns minus 1 or the index of the target. So here I'll take a variable to store that. I'll take variable result. And here if result is not minus 1, then element is found. So target is found at index. Here you can write result. If result is not minus 1, that means the function will return the index of the target element. So we'll write like this, or we'll use else block. Target is not found in the, okay, like this. Here we are done. So what we are doing is, first we'll ask the user to enter the user input for list of numbers as well as target element. Then we'll call this binary search function. Here we'll find the target element in the list of numbers using iterative approach. We'll use while loop, and this function will return index of the target element if the target is present in the given list of numbers. Otherwise it will return minus 1. Then here we'll check the returned result whether it is minus 1. If it is minus 1, then that means target is not found. If it is not minus 1, then target is found at index. So we'll print that. Let's save this and execute this. Number of elements in the list. Let's enter 4 elements. Enter numbers in ascending order. I'll enter 1, 2, 3, 4. Enter target element. I'll enter 4. 4 is found at index 3. Let's take another example. Let's take not found situation. It is not found. This is how we can write a Python program to implement binary search using iterative approach. So that's it for now, guys. Thank you for watching. Don't forget to subscribe to my channel. I will meet you in next class. Till then, take care.